PVC pipe may look round, but it's rarely true from a machinist point of view. So today we're going to actually true up a piece of PVC pipe in the lathe. And this is done just by gradually making fine cuts across the pipe. And what you end up with is a pipe that's spinning true between your lathe centers. And after that, it's easy to put threads on the pipe and then later wire. The most difficult part of this process is cleaning away the thousands of feet of PVC threads that you get as a result of removing it from the pipe. These are continuous chips that form as the tool's cutting. And they offer a nuisance to both the machine and to the operator, trying to constantly clear them away. They love to wrap themselves around all of the gears and parts of the lathe as you're cutting. They also get tangled around the tool and need to be removed from time to time. The lathe is spinning at 255 RPM, which isn't very fast. But as you can see, the chips are coming off fairly nice. They're not melting. It's leaving a nice smooth finish, which is just what we want. There's piles of chips in the process of doing all of this. And on cooler days like this, static tends to accumulate on these and they'll stick to everything in sight. Though most of the time in Florida we don't have that problem. Feed rate's about 5/1000ths of an inch per revolution, so you can do the calculation of I'm removing about 23 inches of PVC from this pipe, 255 RPM. 5/1000ths a revolution. That's a fairly long chip we're cutting here that's going all over the place. Of course, you have to be careful getting near the chuck when you're doing this, because the jaws of the chuck love to knock the ends of your knuckles off if you get them too close. Especially towards the end, they tend to bind up around the pipe just because they have nowhere to go. But they're easily cleaned off afterwards. Approaching the end of our stop. And there we have it, a smooth PVC pipe ready to be threaded. Now I've started the actual coil winding process. I've stopped it temporarily because I made a mistake. The wire jumped grooves and had to stop the lathe, take off the excess wire, put it back on the spool below. But that typically happens when you're doing this sort of tedious work. I'm going to restart the lathe again and hopefully get a few inches of winding at least captured on video. Tedious enough to do this by hand without the camera, so this is the process. Let's see how far we can get. Typically use one hand to supply the wire in the general direction and the other hand to inlay it in the groove. Very nice if we had 3 or 4 hands to be able to do this, but unfortunately it's not the case. The third hand would probably be on the main switch of the lathe to be able to turn it off in an instant if we had to. The good thing about 3-phase motors is, in this case it's spinning in reverse. If you throw it into the forward mode, the lathe, you can get it down to where the lathe will stop almost instantly. Winding coils, you often need that, or else you'll be backtracking for a couple dozen turns, which might mean a couple dozen meters of wire. So we backtracked it. So, where to correct it. What we have to do very carefully is put the lathe in forward to take off the extra wire. And stop it once we're good. Carefully lay the wire back under the spool. And start over again. And I think we'll close for now on this video, just so that I can concentrate on what I'm doing. But this is the advantage of having a threaded form. You see the wire inlays itself in place fairly easily. Just a little bit of guidance needed. And when we're finished, we'll have around 1,000 turns of wire on this form. Nice and neatly spaced. And being inlaid in the grooves, that when you shellac or lacquer the coil, all the windings stay in place perfectly. Now we finished winding the wire onto the pipe, and you can see it's neatly inlaid in the grooves on the PVC. And the winding process itself took about 20 minutes. There were a few snags once in a while. It skips a groove or goes the wrong way, and you have to stop the lathe and turn it in the opposite direction, carefully put the wire back on the spool. It's a little nerve-wracking, but generally speaking it goes easier than trying to wind them by hand without the grooves. Especially, in this case, 48 turns per inch of number 34 gauge wire. So now the coil is ready to be lacquered or shellacked, and pretty soon we'll test it.